Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Aidan comes to us from Dublin City University, where he worked with Microsoft SenseCam, Lindsay Williams SenseCam, and as I understand, you were doing it to summarize into some sort of life log.
Yeah, summarizing more or less.
I don't know if that's part of your talk, but that might be.
It's a small bit of that at the
Okay,
end, so
good.
there is, yes, summarizing millions of images, basically.
Okay.
Yeah.
So you've been working on a thing called SmartLogger, and for those of you who are familiar with, think of her name, Nuria Oliver's work, and I did her hardware a long time ago, or a couple of years ago, where we used an oximeter and Bluetooth transmitter to log on an early smartphone, and I think you're kind of extending that into much more usable and a much later version of the smartphone. So, without further ado, Aidan?
Yeah, thank you, Mike. Thanks very much. Well, hi, folks. As I said, so I'm over here from Ireland myself. Sure, we'll figure it out there anyways. So thanks a million for coming there. First of all, I know you're all very busy in the day there, so I'll try and keep it around 25, 30 minutes or something like that there, and we'll have time for questions afterwards. So as I said, so I'm part of this here group called Clarity here in Dublin in Ireland. So I'm a postdoctoral researcher here, and I've been here the last 3 months, as Mike has said. So first of all, I'll just give a bit of a background to myself, then to my mentor, Chris, and then we'll just talk about, just to ease us gently into what the whole goal of this here project is, and it's using this, for example, your cell phone then to log physiological activities. So first of all, the research group I come from, so we recently got government funding of around $20 million for over a 5-year period. And we've got around, when I counted there yesterday, we've got 85 researchers, and I noticed some people missing, so we've got probably around 90, 100 researchers, and then a support staff here as well. And the interesting thing about this group is we don't only have people working in computing, like we've got personalization and information retrieval, but we also got things like material science, so chemists, sports scientists, and also then people working with, say, physiotherapy or sensor devices there. So we're trying to get this idea of what we call as the sensor web then, so that we've got lots of devices around us there now, and they're, as we say, they're sort of cheap and they're robust, and we're able to log lots of data now about ourselves physiologically and also about the environment as well. And what we're trying to do then is, we say, moving beyond our own research silos. So if I'm a computer scientist, I don't only want to talk to other computer scientists, it's good to talk to the material scientists or the sports scientists as well. So we've sort of a more broad idea of what we like to do. And we're trying to get a couple of demonstrator projects then at the end of this 4-year funded project. And one will be looking at personal health and wellness, so logging physiological data of many different types. And also we want to be able to log the environment around us as well, maybe to detect, say, for chemicals and water pollution and things like that there. And basically the whole thing is what we try and, our motto is to try and bridge the digital physical divide. So that's the background of me coming over here at first. And then to home a bit more into this project there now, one of the most ubiquitous devices around us is indeed the cell phone, so it is. So this is sort of a famous picture here that if you can go off to maybe some of the, we say, least developed countries in the world, and there's no running water sometimes in places, no electricity, but a lot of people do have cell phones, so they do. And indeed, if we compare the number of cell phones to PCs, it's around a 4-to-1 ratio, so it is. So we want to try and piggyback on top of the cell phone in terms of applications. And indeed, it's quite interesting that around 70% of new cell phone subscriptions, they are coming from the developing nations in this world, so they are. So, and as well, another interesting thing is that Bluetooth is now standard in quite a few of the cell phones. And indeed, based on that there was Microsoft, we had an RPF there a small while ago then, where there was 14 universities funded there. And the whole idea was the cell phone as a platform for healthcare. So we want to try and piggyback on top of that ubiquity of the cell phone, or to leverage that there. and to try and come up with technologies that can be integrated with a cell phone, then it might be of benefit to the health and well-being of people in developing nations specifically. So, for example, one application that we developed, or that we displayed at the Tech Fest a couple of months ago, was getting microscopic images. This is a lens that you can put onto the end of your cell phone and the normal camera in it, and then we can get, for example, pictures or images of, say, red blood cells or something like that to see if someone might possibly have malaria. So you can then transfer the image up to perhaps a doctor that is maybe 100 miles away and can get maybe quicker results back then. And another example is here, we're researchers in St. Louis University. They have developed an ultrasound probe then where you can take ultrasound images, say of anything basically, and again you can do it remotely with maybe a trained person in a local village and can send it up to a trained physician then somewhere further away. So this might be very helpful in developing countries. So then another interesting thing is we consider here our lives from when we're a child up to when we get older, and we think of how many times do I visit the doctor? So how many times does my physician get a feeling for how I am? And generally we visit quite a lot when we're younger, and then as we get maybe into our teenage years and 20s and 30s, we don't go to the doctor very much at all there. So for him, sometimes it can be hard for him to make a truly informed decision, or her to make a truly informed decision regarding your health or well-being, so it is. And the idea we like to do is introduce this concept then called lifelogging, where we try and log not just these snapshots in time, but many, many more snapshots in time, that record very frequently during the day. So some of my own research was in the SenseCam, and that was taking 2,000 to 3,000 pictures per day. So we can build a much more complete picture of your life and lifestyle. And indeed, as I said, so this concept about lifelong is about trying to record as many aspects of your life as we possibly can and record it digitally. And sometimes it's for a reason, so it might be for some medical application to see what someone's lifestyle is like. Sometimes it's just for family gatherings, and so we can look back at it. And other times we just do it because we can. We don't know what we want to do with it yet, but it's an interesting technology and we're going to have fun with it. And if we consider lifelogging devices there now, so the domain I would have worked in mostly was visual lifelogging domain, and a lot of past research has been in trying to, how do we miniaturize these devices so I don't have to wear a laptop on my back, and how can we miniaturize these and make the battery life longer and we can have more storage in them. And it's only recently really that we're trying to consider how do we retrieve all that information or understand it better. So the aims of this project there is first of all to utilise the ubiquity of the cell phone there, so we can design some logger for it. It can take in many different sensors and read the data from those. And we'd also then like to review the physiological activities and perhaps in a more intuitive manner then it might be helpful for users. And an interesting thing is that a lot of, when we're given, say, prescriptions for drugs and things like that there, it's against sort of a general base, so it is, but I don't know if we have a better idea of what our own lifestyle is like, and with lifelog data, perhaps then we can begin to individualise what our lifestyles are like, and perhaps we can make better choices. And I'm just going to take a quick drink of water here. And now, first of all, we'll talk about this cell phone data logger. So we will, so the idea is then we can have these different sensors that can record your heart rate, your location, any images that you might take with your cell phone, or any other types of sensors, for example, there, a body temperature one. So then, say if we call this lady Jill or something like that there, she has got her cell phone, because we all got cell phones around us, there's 4 billion of them lying around. What we like to do then is build a logger that can incorporate all these sensors, store it somewhere on the phone there first of all, so we can later upload it to a central repository or data store, and then eventually at another time then we can sit down and review this data here then, perhaps with our medical physician or some other person, or even just for ourselves for our own interest. And the thing about this logger here is that we want to try and incorporate new sensors. So Mike, he's been doing some work here on a neck cuff like this here that you can wear around your neck, and the idea is that there's many different types of sensors in it, and so that a possible application of this is we might want to look at people when they are sleeping there, So what we want to do is to have this framework so we can incorporate sensors like that, which might have maybe some type of microphonic data or galvanic skin response or blood oximetry values. And also, maybe another sensor we might want to do is, for example, one like this here, where we can record your heart rate, and it transmits via the small thing here to Bluetooth as well to your cell phone. So we want to have, so what we've built here is a framework that can include these different types of sensor values. So it can be incorporated along with these here other values. And for a new user or programmer as such, or sensor developer, it should be quite easy for this framework for them to design what we call a new class and then to incorporate it into the logger. And then all the data is stored in XML. So we're dealing with incomplete and heterogeneous sources of data, and we store that via XML, so we do on the cell phone there. So the logger, we spent quite a small bit of time there building that there. But that's, I guess, been done before. Maybe one thing we hope to do eventually with this is to release it as open source there, and it's pretty much ready to do that. So that might be quite helpful to the community. But I guess this has been done before, more or less, so it has, well, we try and incorporate new sources of data, which could be a bit novel. And just to summarize this here, it's for .NET Windows mobile phones, and we incorporate these additional sensors, and it's to deal with these incomplete and heterogeneous sources of data. But perhaps the more interesting thing that we were interested in this project then is how do we review this data or in an intuitive manner? Sorry, you've got a question?
Why around the neck?
Why around the neck? Well, well, in this case, what we're trying to do is monitor a condition called sleep apnea. And the thing about around the neck is you can get voice, so we can see if I'm sleeping, so if I'm breathing or snoring, or not breathing as well. So you can get, so that might be a useful source of information. So, and it's just, yeah.
I'm sure you must have looked at Louis Oliver's work when they not simulators, right? So
Yeah, so there's also oximetry in built into that as well. So there's a small, and we're going to make it there. In fact, we have a much better version now already. So there's a small clip here that you can put on your ear, and then it gets your pulse oximetry and heart rate values as well. And as well, we're going to incorporate into that accelerometer values, so then you can see perhaps what poise you're in when sleeping as well. So this is sort of a work in progress. It is, and actually I'll mention that a small bit later then too, so hold on.
when you refer to as platform sensors, are you talking about things where people can just plug in the sensors?
Yeah, so the thing is that the sensor should transmit via Bluetooth, and then the cell phone then can sniff for the Bluetooth devices around. So you would, around 5 lines of code or something like that there, you should be able to incorporate a new sensor type into that there.
Software on the cell phone, not the hardware.
Correct, yeah, it's a software Windows mobile application, so it is, or Windows mobile logger. Okay, hope that's fine. Yeah, we're good.
GSR?
Yeah.
What type of sensor is a GSR?
It's a galvanic skin response, so it is. And I think now, correct me if I'm wrong, that it looks at the level or analyzes your sweat, so it does, and then you can tell, and it can be somehow correlated, or people claim it can be there. Now, I haven't read this paper so closely that it can be correlated then with emotion. So maybe, for example, how angry you are, or an intensity of emotion there now. So that's been claimed. Now, I haven't read these papers very closely, but that's the claim, so it is. Okay. So a lot of past research that what I found, anyway, myself, and reviewing these data, we look at it as in our typical ER type screen of a heart rate, and we just look at the graphs there. But if I'm wondering, why was it perhaps higher here? It sometimes can be hard to remember that there. So we'll go through just a very brief and small, simplistic overview of the human memory system. So how can we perhaps design a system that helps us so that we can consider these aspects here to make more informed decisions or to exploit the human memory system in a better way? So we've got sensory memory, first of all. That's just only lasts a couple of 100 milliseconds at most, so it does, and it's things so we can process images in our brain and things like that there. And then we've got the short-term memory, and that probably only lasts around 5-10 seconds, no more than a minute, I would say, and we can only remember generally maybe 5 to 9 items in that there. And things like, what will I do next? Do I need to go and get a cup of tea or put sugar into my tea? Things like that there. But we're more interested in the long-term memory. So that's split up into two different things. We've got procedural memory. So that is things like learning skills, how to kick a football or how to tie your shoes, things like that there. And declarative memory, which is then split up into semantics. So I know Paris is the capital of France. I know that my football team haven't won the big championship in 17 years, and it gnaws away at me every day of the week, so it does. And as well, we got these autobiographical memories then. So it's remembering things about my life. It's remembering that on Saturday I was out at the outlet mall at North Bend, or it's remembering that I was away with Mike there last week. Then we're into the city centre to meet some researchers in the UW medical school. So, and then we consider a bit more research in these autobiographical memories. So and one thing comes up here is that cued recall is better than free recall. So if I ask anyone, what did you do on the 22nd of February? You're stumped. So, but then if you give a cue or something like that and say, well, that was the time TechFest was at, so then you say, oh yes, that's right, and I remember going around 2 or 3 o'clock, and then you provide some images, you're providing more cues or something like that, I can remember better. Oh yes, that's right, I was talking to Tom at that time, so I was. So it's about providing, so we provide these cues then, it's easier for us to provide reasons or to remember what we were doing. And some other things then, memories can be temporally encoded, so we're pretty good at estimating when things happened. We mightn't get it exactly right, but we can remember relative to other things when things happen. So I remember that I went back to Ireland since TechFest, so I can perhaps use these memory hooks of timelines. And another thing is that some distinct memories are more strongly encoded. So I might remember that I went for a run on Tuesday and I was absolutely gasping for breath because it was the first time I'd ran in 2 weeks, so it was. Or other things I might remember is that, for example, that the former president of India was talking today there, and I was watching that there seminar on the webcast, so it's not every day I look at maybe a former government leader giving a talk at Microsoft, so I might remember that better than the fact that I had whatever my normal 4 sandwiches earlier on today, or what I had for lunch, because that's a reoccurring event. And then as well, some memories are stored by association, so if I think on fish, the next thing I think of is not football, so it isn't, we associate things not alphabetically, but or we remember things by association. So if I see Mike, then I might think of some work we did with SmartLogger, and then I might think of someone else. So we operate associatively. So our tech set, if we want people to review their physiological data, what we'd like is to effectively review that there, first of all, by logging the data on the cell phone. It provides us with these potential cues, so then we can see when heart rates were high or what locations you might have been at. And also then we want to do is be able to query data temporally, highlight more distinct events. We use that with the chart so we can see when heart rate was higher at times. That might indicate a more distinctive event. And then to associate related events, so to associate a high heart rate with maybe with location or with some pictures around that there time, so we can better understand why my heart rate was high or low at a certain time. So we come up with an interface like this here then, which is sort of 3 different panels, and up to the top left here, then we would have the query panel, so that's where we construct our queries then, so we can construct when things happen temporally, so then we can query by dates, and we can constrain it to different days, or we can compare data across days, and then obviously we want to chart this physiological activity here. In this case it's heart rate, and we can see that more distinctive things might stand out, for example when your heart rate is higher. And finally then we want to provide a context that's around, why was my heart rate very high here? So we want to see a context around that, if we can provide some location or image information, which might help us then better remember or reason why our heart rate was 150. It might be because I was out for a run. And in this case here, where we're going to show the heart rate was high. Why is that? Because I was up at the pro club there, so it provides a reason. So it's not that my mentor Chris gave me more work to do and I was having almost a heart attack because of that there. So provide some reasons. So that's we can provide location context, or we can also provide some image context as well, because there's quite a bit of literature that supports the fact that images are very strong cues to remembering things. So they are. So next, say this is a normal day, and what was I doing here? Well, I was in my office as normal. I was sort of testing out this little neck sensor as well. So it provides another reason, or helps us explain things better. And indeed, we want to be able to some adaptability in this interface. So we want to look for patterns across different days. So perhaps we sit down with our physician, so I can compare. What I see here is I can group the graphs by day, and I can see perhaps patterns maybe around 4 o'clock in the day or 8 o'clock in the evening, what might be happening. And you can imagine looking at this over a number of days then too. And as well, we can look at different types of data sources as well. So we normalize them all into the one scale, so we do. And so you can see then how speed, so I think that's based on the number of steps on this here heart rate monitor, how HIT might relate to heart rate for some reason, or how blood oximetry might relate to those there too. So this is just a case where we log the data, but you can imagine then in sleeping case, we might want to see how blood oximetry might look in a graph like this compared to breathing or something like that there, or to heart rate then too. So by being able to easily query this data, then we can perhaps see potential relationships. And indeed, then just sort of smaller things, then you can delve deeper into the data, so we can get the timeline closer in to look more deeply into events just through normal zooming or scrolling of the timeline. And then we can adaptively constrain some of the data as well. So I just want to see what happens perhaps on weekends. Do I sleep differently then, or do I have some other physiological activity where I'm perhaps more active at the weekends or less active at the weekends than I should be? And we can query that data then adaptively over time then too. And indeed, as I said, one thing we're hoping to do there, it's in the pipeline at least anyways, perhaps make some open source release of this here then too. So which might be then helpful for, first of all, maybe sensor device researchers, so they don't have to concentrate on how do I visualize that data or display that data in some way. So now you can just plug in your sensor quite easily into this here framework, and then it will show up on the interface we've just shown, which can easily incorporate these new sensors. And as well, another interesting thing might be people who are interested in the machine learning then, so they want to gather lots of data, but they don't want to spend time trying to configure devices and things like that there then too, to put it into the database that we have and do their own machine learning algorithms on that then to identify patterns. And maybe as well, some health conscious individuals might be just interested in logging my heart rate data over some time and able to query it then in a different way to perhaps some applications that are already out there. And I'm going to show then some ongoing work here now, just in the last 5 minutes or so. So one use case of this, as I said, is this application into the sleep apnea here. So Mike, he's been mostly driving this, so he has, but we're working along with him. So he's, as I said, developing this sensor here that we're just talking about, that has these different sensors in, perhaps see the poise or the breathing or blood oximetry values and things like that there. Excuse me very much. And we're in some preliminary discussions here then in with doctors in the sleep disorder centre and UW here as well, just to see if there's anything that could potentially be interesting to them. It's good to get their feedback there too. And it sort of comes back to, say, at the very start there, I was talking about, it's sometimes we don't want to be stuck in our own research silos. We want to collaborate across multiple disciplines as well. So it's good to collaborate with these people who have a very different perspective to ourselves as well. And indeed, as I said, the sleep apnea, something like 12 million Americans have that. And to try and diagnose at times, we might have to go into a special sleep lab. And it can be hard to see how a person truly sleeps in an unusual environment like that there. So imagine then we can monitor people in their own homes over a month or something like that there. We can build up a much more complete picture, and that's the whole life-logging vision then, so we can make better informed decisions. And as well, there's a couple of future challenges. So then this project was displayed at Tech Fest, and that was very helpful to us, because then we got to see potential work that could be done. So there's Kristen Lauter here in the internal research department, and she has got a cryptography group. And what she's interested in looking at here then is the security of this data, because it's your medical data, your physiological data, so it's intensely private to you, and you don't want to release it to other people. So we've got to consider these privacy concerns, and we've got to consider it both ways as well. So not just from the device being uploaded to the phone, but also from the phone, so that some other device can't, or some other phone can't control your device in a certain way. So I think it was recently they found out that, and with pacemakers and hearts, that there's a certain signal that you could send to those to reset them or turn them off. So obviously that's pretty important to security, so you can't turn off somebody else's pacemaker, which is pretty severe, so it is. And as well, uploading data from the cell phone to your central repository as well, you want that data to be safe and secure. So, so the cryptography group in here, they're interested in looking at that longer term. And another interesting thing is, where do we store the data? At the minute, we just store it in a SQL database, but longer term, we would like to store it in somewhere like the Health Vault, so the Health Solutions Group and the work that they're doing. So we're just having some interactions with those guys at the minute there too, to see longer term how we can integrate our own project and so that the data is stored in Health Vault then. So they're interested in the privacy of the data, and it's only the individual then that releases their data to who they want to release it to and things like that here. And another thing sort of further down the line that we're just having very preliminary discussions with then is, so people who are interested in machine learning might be interested in this here, so that we can give some recommendations then to people based on, or looking at the patterns. So perhaps if we had a certain pattern here, it's just a screenshot image, but imagine it was meaningful data, that perhaps then we could see over a while that you might be showing some symptoms of sleep apnea, or we can imagine even further into the future, it could provide maybe symptoms for multiple types of conditions that perhaps you might want to go then and visit your medical physician to get checked out more closely. And indeed, this will sort of tie into work that we've done ourselves here in Dublin on the sense cams. The sense cams, this camera you wear around your neck, it's very small, lightweight, and takes 2,000 to 3,000 pictures per day, which is around 1 million a year. And one thing we're doing is we've manually will annotate around 95,000 images, and across these what we call 27 concepts. So we've got things like sky, grass, buildings, working on PCs there somewhere, when am I eating, and we've trained classifiers on those there, and a number of those are of a reasonable accuracy here as well. And the interesting thing about that then is that we can begin then to compare lifestyles across social groups here. So here we have 5 users, and we can then begin to compare. So this black line is the median of what you would expect this social group here to do. So we can see that user 2 is the hungry so-and-so in the group because he eats more than people. Or we can see that user 3, he sees more external views of vehicles. Why is that? Well, he cycles into work every day, so he's seen all these external views of cars and buses. User 1 drives a lot more than the rest of us, and the reason for that is he's the only guy who does drive out of us. User 4, he's the very diligent researcher. He reads more than the rest of the people there, and anybody that knows that had been in our research group, they'd know that Huan in our group, he works much harder than the average person, so he would read much more than us. So we can begin to see things like that. You can imagine then perhaps having some little Facebook application or something like that there, like who has been more active this week out of our small little social group, or who's working too hard and becoming a boring so-and-so. And one last thing I guess to consider is the fact that at the minute we're transmitting via Bluetooth there, and that's quite power intensive. So an interesting thing then to consider is in future will be Zigbee. So it is so it's a lower power wireless transmission protocol. But I guess that's probably a bit further off in the future, because at the minute Bluetooth is the mainstream on cell phones, but we'd hope perhaps in future it might be something like Zigbee. That means then we can run loggers for longer, and they become more common as well, because a lot of people don't like to run loggers at the minute, and rightly so, because it drains the battery in their phone. But then if it's lower power, then we can begin to gather more data, which means we can make better decisions then too. So in conclusion, last slide here. So we're trying to utilise the ubiquity of the cell phone by building this logger to make it, and we've tried to build this framework then where it should be quite easy for people to incorporate new sensors into that, and we'll try and make an open source release of that, or it's in the pipeline at least, or we have plans for that. And then to review these physiological values, we're trying to make it easier and intuitive for people to do that there. And as I said, there's lots of exciting things to do in the future there, so I think this project has some legs to run there yet, so it is. And thank you very much, folks, for your attention. I appreciate it very much. Thank you.
Any questions?
Mm-hmm. Yeah.
So it seems to me that that these sort of two elements of the work are really, they could go orthogonal in a way, aren't they? I mean, the sort of reviewing the physiological data, I mean, that's really just telemetry, trying to come up with a successful way of surfacing that telemetry.
That's right, and to provide the contextual information around it then to help remember it better, And and it relies on the first one, and obviously to go and gather the data too,
So I guess I'm wondering whether there's an interest in, I'm obviously interested in looking at a lot of different approaches, but like more continuous data, like for example, glucose monitors / insulin pumps, and those things are kind of gathering data, all continually monitoring insulin levels.
Well, we would love people who have those and say they did transmit via Bluetooth to actually try it out on this framework then too, and then to see how it looks when you graph it and stuff like that there. So the idea is that we would be trying to encourage people who have those sensors to get their hands dirty then, and to try and more or less stress test the phone to see how it actually does work. So that's sort of a goal of the thing, that we're trying to encourage people and what those sensors to use.
A lot of commercial makers of instruments like glucose meters are actually putting Bluetooth in there. Have you looked at how quickly that's happening? And number two, what exactly would you put out as open source? What's your toolbox going to look like?
Okay, so first part of the question as to how prevalent Bluetooth devices are now, I don't have any statistics on that. So, like we purchased this here device from, I think it was New Zealand, so it was, to monitor the heart rate data, so just a standard one like this. And I guess the advantage of that over your, say, your polar heart rate monitors, now I don't have to wear, so imagine I have 2 or 3 monitors, I don't have to wear a lot of jewellery or watches here on my hand with these different monitors. So I think they are coming more in the Bluetooth, but it probably will be a small while yet, because I guess a lot of manufacturers, they want to consolidate their place as well, so people have to use their own software and devices to upload the data. And regarding the setting thing, how much we want to make open source of that there, the plan is all of it. So the pieces, well, I guess there'll be sort of like 2 main pieces. One, the actual logger for the cell phone, and then the other then is the actual the database and the interface application, and to review that data. And we've tried to make it in such a way that it should be easily extendable, or research code as easily as extendable as we can make it. So that's the plan at the minute.
How are you going to get all the caregivers to assimilate this information? Obviously, you're not going to bring this DVD of raw data and say, this is what I've been doing the last couple of years. How do you get them to assimilate that? It'll be more cultural than anything else right now.
That's a good question. So I guess we would hope that their interface helps it easier to drill down to a more macro level at the minute there. But I guess then it requires sort of one of those ongoing stages of the project then for some development of that to come, particularly the work of the machine learning group then. So I'd say right now that it's just you review the interface that we showed at TechFest there, and probably it is easier than giving them the DVD and an Excel spreadsheet in a minute. But I guess it's probably another year or 2 down the line until we apply some machine learning algorithms in that there too, so we can begin to recognise some patterns that might make it easier then for them. Bob?
In terms of making available to physician, whatever, you've already said you're looking at a health vault interface, so there you have the data, the physician should have access to the data once the user doesn't. So there's a platform that you can use to talk to physicians, but you still want to have some filtering mechanism. I mean, there's your Bluetooth and your ability to do it, so your time is constrained on the cell phone, how often you run. How long do cell phones run when you're talking Bluetooth all the time? I mean, I know when I have my headphone on and driving and whatnot, my battery goes down much faster if I'm spending time in the car than here at work.
That's actually a very good question. So it is, as most days data, I probably only logged 3, 4, 5 hours at most, I would say, every day. So it's generally when I was in work, and I would notice the battery is running down quite fast as well on that. even for those small amounts of time, because with our SenseCam work, we're wearing it maybe like 16 hours a day, so we were. So, and then when something becomes wearable like that, and you forget about it, obviously, and people are going to log much more data, and that's how we get people having millions of images and things like that there too. So the thing then we did with the Bluetooth cell phone then was to log the data less often. So like maybe profile maybe once every minute instead of once every second or something like that there, and that can increase the time. But I guess then a thing we'll have to think about in future then is how fine or coarse-grained do we want the sampling to be of the data? So I don't have an answer to that at the minute.
Well, they're a lot more
You can be
efficient.
caching at different levels. So I mean, I think you can sample and upload and do whatever. But if Zigbee or some lower power version of it is the target, is Bluetooth going for lower power as well, or everybody's looking for this?
If all you want to do is data log, you could probably spend 1/100th the power just putting the data to a local SD card, right? Locally logged, no processing at all, process in a burst mode later. So there are lots of other different ways. But there is a faction of the Bluetooth standard that is looking at lower power, but most of them are looking at higher bit rates, unfortunately.
But then you know, the SD card or whatever, if you're on the phone, that's great, but if you're talking about inside the device, where you're going to cache and then pull less frequently, I want my device cost to be really, really low and small and as well. So
Yeah. So that's what I'd love to see in Windows Mobile 10 or something like that. Yeah, that we have a very low-powered passive logger in the background running on it. But yeah.
you need a nuclear pile that's, you know, fingernail size, right?
Yeah, that's it.
So I came in a little bit late, but did you go over the Bluetooth profiles that you're supporting?
Just refine that question a small bit more then.
I'm wondering which Bluetooth profiles that you're supporting for connecting to the devices.
So it's done via a serial port on the phone, so it is. So the person registers the serial port, and then in your so in the code, then you just specify what COM port that is, and then there's around 2 or 3 other small bits of lines to change the code, and that should be it in theory then.
Right. Have you heard of the Bluetooth health device profile?
No.
Okay. So that's a spec that's out right now.
Okay.
There's an organization called the Continual Alliance.
Okay.
It's like a consortium of a bunch of member companies, and they point to certain standards. They have like a stack that they provide their guidelines, and they provide USB personal health device profile.
Okay.
They also provide Bluetooth HTTP.
Okay. And could I ask you to forward that link on to me, if that's okay? Or
Sure.
okay, thank you very much.
What does it offer as far as power efficiency? Anything?
Well, the health device profile, I think, is still using the high-power Bluetooth, but the Continual Alliance itself is trying to figure out their lower power guidelines for their version 2. So I think they're going to be using Bluetooth. That's what I hear. We're not, I'm employed at Microsoft, and we're not members of the Continual Alliance, so we don't really have visibility into the V2 yet, but where it is that they'll probably be using low-power Bluetooth for that. And I think they've been working on that spec already.
Okay, thank you. Yeah.
Maybe I
Yes.
understood this, but did you build on top of the SenseCam software, or did you write from scratch?
Built from scratch, so it was. So the SenseCam is like a.
So why not?
Yeah.
Why not build on SenseCam software?
Well, I guess first of all, in terms of the data logging, so it's completely different platforms that they're on. So logging data, that's 2 completely different things. Then as regards to viewing the data, then I guess there's very different characteristics with the SenseCam. So I said that images, they're very strong cues to information, so they are. And with the SenseCam, as of yet, we've only briefly looked at logging heart rate monitoring or physiological activities, and we had an interface somewhat actually similar to the one that I showed there, but most of the SenseCam working was just purely image processing and processing on the images and to show the images, and we thought it wasn't so helpful then to show, say, accelerometer data or something like that, because the image data seemed to give the stronger cues then as to regards what I was actually doing at a certain time.
Edie, can you go to the
Yeah.
next slide?
Yeah. The next.
Yeah, the last one. This one, yeah, thanks.
Oh, sorry. Yes.
Yeah.
Right, so this is our SenseCam website then, so that's where all our publications are on the SenseCam. So it's quite interesting that the SenseCam, there was recently mentioned in Science magazine, and I think a week or two before that in Time magazine as well. So it's a good publicity spinner in a way, the SenseCam, because they've done some studies, fMRI studies on people with memory deficiencies, and the SenseCam seems to be quite helpful for helping them remember things that they were doing perhaps 3 or 4 days ago that otherwise they might not remember. So there's researchers in Addenbrooke's Hospital in Cambridge in the UK that are looking at research on the actual patients themselves, and where our work then comes into play is regards to how do you manage that collection of 1 million images a year or something like that there, and how do you summarise that information. So a lot of that will be described in the website here that we have, and that's what my PhD topic is in there too, and that's what most of our work is in. And when I go back to Dublin on Monday morning, that's what I'll be thinking about again. So, Sorry?
Not a group talk. Just making sure I didn't miss my.
Okay. And yeah, thanks a million for your attention, folks, and I appreciate you taking time out of your day there. Thank you very much.